Hi there, and welcome to our webinar on unit testing your MobileCaddy powered custom Salesforce mobile application. So first of all, let me briefly introduce myself. I'm Todd Halfpenny. I'm the Chief Mobile Technical Architect here at MobileCaddy, where we supply an application delivery framework targeted at building fully custom, fully network resilient mobile applications for Salesforce users. One of my main roles here at MobileCaddy is to look at and improve the developer's workflow to try and ensure that they're getting the best use of their time and the applications that are being built are as robust as possible. So today we're going to briefly look at unit testing within your applications and how, when using MobileCaddy applications, unit testing can be used, the tools that we provide, and how you can go about implementing them. We're going to start off by looking though at the concept of unit testing really, and also how you can go about making sure that the code you're writing is as testable as possible. So let's have a look at the concepts then of unit testing. Really, this is one of the key tools in the developer's tool chest, and what you want to be doing is increasing your confidence in your code's resilience as you go through releases, checking that new features and bug fixes that have been put in aren't breaking anything else. So unit tests really should cover very small chunks of code in a kind of atomic manner. You don't want to be testing huge scopes of code and huge numbers of lines of code within a single unit test, because you muddy the waters. So testing smaller chunks of logic is the way to go. The test really as well should not be dependent on any other modules or classes within your project or even external systems. What we don't want to be doing is having our unit tests rely on, say, a third-party REST server. In our case, it might be Salesforce. We certainly don't want to be wanting to test that the responses back from Salesforce are looking right. Not when it comes to unit tests anyway. Lots of folk out there and the tools actually aim to look at coverage of your unit tests. And although this is important, we actually want to be focusing on good quality tests. Those are going to be stretching your code as far as possible. And that's what we're going to be trying to aim for. Examples of this might be looking at checking for empty responses from a database query, or handling invalid parameters being passed into your functions. These are having kind of limited scope tests, but we want to be stretching the code inside each of those functions as much as possible. A kind of a side benefit really of unit testing is kind of making the path towards a test-driven development approach. And one of the key benefits that I see out of this that's kind of potentially not intentional at the start is that it can really help you decide how your code and your project might be structured, where you might modularize things, where you might break code out, where you might have reuse. All these smaller functions become much more testable and hopefully therefore much more robust as we go forwards. Before we get on to actual unit testing, I think it's a good idea to think about how our code can be written and how we can place our business logic throughout a project. So here we're talking about Angular 1 at the moment with MobileCaddy, and I'd like to pull on this excellent quote here from John Papa. He talks about defining logic in a controller by delegating it to the services and factories. So John Papa is renowned in the Angular world, and he's actually written a couple of style guides for coding for Angular 1 and Angular 2. And when it comes to Angular 1, where we have these controllers and services, he's got a couple of key points that I think it's good to go over to make sure that we're getting the best out of it. So what we're saying here is really that the controllers should be very light. And what you want to be doing is putting logic that might be reused by multiple controllers into services. Let's say, for example, that we've got some fairly complex calculations, possibly around calculating tax or something like that. Or maybe we're reading from a database and we're having to read a couple of tables that are potentially unrelated in the database form, but we want to return a single enriched array of records. That's the sort of thing where we don't need that in the controller. We'll also think about where we might be interacting with external systems. You don't want to be having that in your controllers. So like Angular has its HTTP service, we would do similar here, where you're interacting with external systems or data sources. A benefit of doing this is actually that our code becomes more easily isolated for unit testing, and actually the testing itself is easier as well. Angular has some excellent ng ng mock libraries available for unit testing, and it means that here we're able to, with the code in our services, much more easily test those. As we touched on earlier, we're trying to hide implementation details potentially of database stores or JSON formats, and we also want to remove dependencies and hide these implementation details from the controllers, putting them away into nice kind of atomic services. We could think, for example, that if the source of our data changed, say from perhaps local store to an encrypted database table, so maybe an encrypted data soup, we wouldn't want to be updating our controllers and things, and if we had a service to handle that, then it'd be a much cleaner refactoring, and our app would still run without having to change a whole bunch of code. In essence, we want to keep the controllers focused on what they want to be doing. And this is handling data to and from the DOM and UI events. So these are just kind of 4 points that John Papa puts down in his guide. I highly recommend reading it, and I believe we can post the link up at the end if no one has that. We'll move on to now running and configuring these unit tests within a MobileCaddy application. We're going to approach this as if all the MobileCaddy apps have been built from one of the MobileCaddy shell apps, whether or not that's an adapted mobile shell app that you've now got in your own specific template, or it's straight from a base shell. So each of the shell apps come with Karma and Jasmine listed as dev dependencies in their package.json. And they also contain the grunt tasks and a folder setup in place for these tests to be run, so for the built-in code, and also extended for your own services. These can be run from the command line within your projects directory with a straight grunt Karma command. So nothing too complex there. What happens when you run the grunt Karma is your any tests within your test directory will be run according to the Karma config in there, and you'll get some kind of output as to how many had passed and failed. What we also do is we've included a interactive coverage tool that lives under the test/coverage directory, and this is an HTML page that can be loaded into your browser, and you can then dig down into the services. You get some idea of the statements and branches that have been covered in terms of percentages. And you can even actually dig into individual service files and see which lines of your code have been covered, so you know where to target next. As I said before, it's probably worth noting again that we want to be focusing on quality tests, not just coverage. But of course, if you've got good coverage, that's better than nothing. So I have a quick overview now of writing a unit test within this kind of MobileCaddy framework using the tools that we've described. And we'll take an example here that I've got this myservice.json, and in there I have my get1 function. And all this is doing is returning the integer 1. So to unit tests, what I'm going to do is actually for each of my services, I'm going to create its own tests folder within the test/services directory. You can see here the bottom part, I've got this myservice.test.js. I'm only showing an extract of the code here, but all the code for this webinar is actually written down in documentation form on our developer.mobilecaddy.net website. And that could be accessed there. But anyway, yeah, this is a subsection of that code. And what we can see that, first of all, we're setting up some code here to make sure that my service is injected in. This is to do with the fact that when I'm running Karma, my code isn't going to be bootstrapped in the same way that my app would be if it were running. So we want to make sure that everything's accessible here. The second part of this, my service.test.json, is my assertion, really. This is my test case. And it's in the it block, and I'm saying it does get 1. I'm then assigning my variable a the result of a myService.getOne function call. And that should hopefully be the integer 1. And so what I'm doing in my assertion in this expect line is to say I'm expecting a to be 1. And if we run this, we get a pass. All looking good so far. So let's look at a kind of MobileCaddy example now, and where you might be needing to add some stubbing and mocking. We want to be stubbing and mocking the MobileCaddy utils, just like we want to be stubbing and mocking the HTTP calls or any other kind of service functions that we might be calling within our application, because unit tests, again, should be limited in scope. So let's say that my service.json has now got this read function in here, and it's going to be resolving a promise. And within this function, what I'm calling is a devutils.readRecords on my account table. This call is going to be reading all of the records that are actually inside my accounts table and then returning it back in a resulting object. My service is then resolving this, but actually I'm just resolving the records attribute of my resulting object. And I know that this is going to be an array. Of course, if this fails, then I'm going to be rejecting it. So let's move on to see how we might start testing this. So first things first is I'm going to set up my spy for my devutils calls, because I don't want this devutils read record call to be really going out to the MobileCaddy libraries. I want to have control over the responses to that. So I'm setting that up here with this jasmine.createSpy, passing in the name of the service, and then there's an array of function calls that I'm going to control. Here I'm passing in just the read records. We're then using the providers here to make sure that that's available for me in this utils mock variable. We're now looking at getting the tests file, and here I've got my test case, which is saying it does a read. I probably should make that more semantically correct. And one of the first things to notice here is I'm passing in this done into my function. And this is a function call in itself provided by Jasmine, which enables me to correctly unit test when it comes to asynchronous calls. We'll get on to how that might work a bit further later. The first thing to note is that comes in here. What I want to do in my test case is obviously I'm going to be calling this devutils read records. And what I want to do is make sure that I'm mocking that successfully and returning a result that means I'm stretching my code. So first of all, I'm going to set up this mock response. And what we can see here is I'm returning a promise, and actually I'm returning an object containing this records attribute that in it is itself an array of 2 items, one with ID 1 and one with ID 2. The next chunk of my code is actually really what I'm calling my service. So I'm doing a myService.read, and in then block I'm getting my result back. And what I want to do here is to make sure that that result is what it should be based upon the mock response that I'm sending back. See here I'm saying, well, I'm expecting a result object, and it should be an array and have length of 2. If you remember that our service was actually not just resolving the response it got back from the devutils, but it was only sending me the records attribute, which was the array. To complete the test, I'm then calling this done function in here, which closes off that asynchronous wait. This kind of mocking approach could be done for any of your own services that might be being called within your code. And it can also be used for the other MobileCaddy libraries. There are plenty of examples up on our GitHub repo. But you could see, for example, if your code was calling the sync service that's built into the shells, that you would want to make sure that that was returning you some result back so that your unit test could pass. Now, one of the beauty of unit tests and some of the amazing tools that are around these days is the automation of these. So within MobileCaddy, we're using the Travis CI for our repos that are hosted on GitHub, and we're using the Bitbucket pipelines for those hosted on Bitbucket, and there's many others for all the different tools available for you. I mean, really good thing about these automated tests is that you're not having to rely on developers potentially from running these themselves. If you set up this kind of CI step, then these tests will be run automatically, and they can be run off of Git events such as Git pushes, pull requests, merges, etc. And the benefit, for example, if you have your tech lead hat on, is that you can get alerts for these events. So I can have email notifications when a push is a commit is pushed up to Git for my develop branch, for example, and I can be notified upon any failures of those. As well as in the test runs that come out, whether they're pass or fail, as we had earlier with our coverage checker, the config that's available in the MobileCaddy apps by default will also set a text version of a coverage output for your tests. So I'll get a percentage of line coverage, for example. And these automated tests really give you a peace of mind that they're being run all the time for you. You're not having to depend on anyone remembering these things. And of course, you could push these further into your automated test flow. Just a couple of links here that might be of use. There's, as I said, this webinar is based loosely on a documentation guide that we've got up about unit testing. That has all the further code available, and that's available at developer.mobilecaddy.net and searching for unit tests. We also have more example codes of, especially of the mocking, is available within the projects on our GitHub repo, and that can be found at github.com/mobilecaddy. So that's really the base of what I wanted to cover in terms of unit testing, with a key few points really. First of all, you want to be doing unit testing. This is going to give you the resilience and confidence that you need in your apps, especially when we're talking about pushing many versions a year and potentially having many different developers working on the same projects. To get your unit tests working, you really want to be focused on getting your code structured correctly in a way that it makes it more testable. So try and keep your controllers very logic light and pushing logic into your services. The MobileCaddy API can be mocked, as should everything else. You want to make sure that your unit tests are nice and scoped out, really. Testing only what's in them and stretching the code within there. And by doing this, hopefully you'll be identifying errors much quicker and not getting those bugs out into live. All right. So thank you very much for listening. I hope this has been useful. And please come and check us out and get in touch with us on our Twitter. And also visit our developer site for any documentation that you might need. So I'm just going to turn to the floor quickly to see if we have any questions in. Yes, there's one here. Okay. Oh, this is a very good question, actually. It's in relation to the data that you should return in your mocks. Should we be returning large data sets and what to include? Yes, that's a very good question, actually. And considering that the MobileCaddy serve command has the ability to record all of the transactions from Salesforce, you could potentially copy huge swathes of JSON relating to, I don't know, for example, your entire accounts table into your mock result of your unit tests. But actually, that's not going to be giving you probably the best use of your time and the best use of your tests. You don't necessarily need large data sets for unit testing. What you do want to be doing is having data that stretches your code, making sure that you're testing optional parameters. So, for example, if your service was doing a read like I was on my account table, but maybe you were doing you were ordering that return result back to your controller, then you'd want to be making sure that your unit tests covered a few scenarios that catered for potentially where you had, I don't know, let's say you're ordering on first name and surname. Maybe you'd want to have contacts with kind of identical first name, surnames, and see how that handles. Perhaps you were enriching your data, or maybe you were excluding results, filtering them. So making sure that your mock data includes those fields that are being used within your service. Really, that's what you want to be doing. You don't want to be putting too much mock data in, because you then cloud yourself and maintenance becomes a bit of a nightmare. So yeah, stretching your services in terms of unit testing, mock data is the way to go, but doing it in a controlled manner. So you certainly don't need everything. I wouldn't need to have all of my fields on my accounts, for example, in my mock data, if my service was just ordering by, let's say it's ordering by age and then filtering on sex, for example. I wouldn't need to have their contact telephone numbers or anything like that. So yeah, I hope that answers your question. And I think that's it actually from the floor. So thank you very much again, and I hope this is useful. Bye-bye.